Wondered why things have weight.
Yeah.
Like, what's actually going on at, like, a fundamental level? That's
Okay.
what we're going to be diving into today,
Great.
the
Yeah.
Higgs boson, and how it helps us understand the concept of mass.
It can be far.
We've got a study guide, an
Mm.
FAQ, even a video script that, like, tries to make this mind-bending stuff relatable.
Right.
But first, before we jump in, what is mass? I think most people would say mass is just how much something weighs.
Right.
But our sources make it clear it's actually about resistance to acceleration.
Yeah, that's a key distinction. It's not about how heavy something, feels here on Earth,
Right.
but how much it resists being pushed or pulled. You can imagine like trying to push a shopping cart versus a car.
Oh, yeah?
The car has way more mass, so it takes a lot more force to get it moving.
So it's more about inertia, how much an object wants to stay put or keep moving in the same direction.
Exactly. And here's where the puzzle starts. The standard model of particle physics, which is incredibly successful in explaining other forces and particles, initially predicted that particles should be massless.
Wait, so the rule book of the universe was saying everything should be zipping around at the speed of light.
Pretty much, yeah.
That's obviously not what we see around us.
Right. Yeah, that mismatch between theory and observation was a major headache for physicists.
Yeah.
The standard model was missing a crucial piece, something to explain how particles get their mass.
Enter the Higgs field.
Yes.
This is where it starts to feel a bit like science fiction.
Well, it is a pretty mind-bending concept.
Yeah.
Imagine an invisible energy field that permeates all of space.
Whoa.
It's not something we can see or touch,
Right.
but it's constantly interacting with particles.
Okay, so this field is everywhere, kind of like a hidden ocean that everything swims through.
Yeah, I like that.
Okay, and the Higgs boson, that's like a wave in this ocean.
That's a great analogy. The Higgs boson is a ripple in the Higgs field, a way for us to actually detect its presence.
Okay, I see.
Yeah.
And it's this interaction with the Higgs field that gives particles their mass.
Right.
That's where the cosmic molasses idea comes in, right? The more a particle interacts with the field, the more stuck it gets, the more mass it has.
Exactly. The Higgs field provides resistance, and that resistance is what we perceive as mass.
I see.
You can imagine, like, a celebrity trying to walk through a crowded room. Their popularity makes it harder to move, kind of like a particle with high mass interacting with the Higgs field.
I love that analogy. So this isn't just some abstract idea. It has profound implications for how the entire universe is structured.
Absolutely.
Yeah.
Without the Higgs mechanism, stars wouldn't form.
Whoa.
Galaxies wouldn't hold together.
Okay.
We wouldn't even exist.
Wow. That's heavy stuff, pun intended.
Yeah.
But how did scientists even come up with this idea of the Higgs field in the first place? It sounds almost too fantastical to be true.
Well, it's a testament to the power of theoretical physics.
Right.
Peter Higgs, along with other physicists, proposed this mechanism back in the 1960s to solve that mass mystery in the standard model.
So they had this theoretical framework, but actually proving it was another challenge altogether.
It took decades of research and development.
Wow.
Culminating in the construction of the Large Hadron Collider, the most powerful particle accelerator ever built.
Wow.
It was a massive international collaboration.
Yeah.
A testament to human ingenuity and our drive to understand the universe.
And it was at the LHC in 2012 that they finally found the Higgs boson, this tiny ripple that confirmed the existence of the Higgs field.
Exactly.
Wow.
You can imagine the excitement of those scientists after decades of searching.
Yeah.
Finally finding this elusive particle that confirmed a theory and revolutionized our understanding of the universe.
Okay, so we've established that this Higgs field is a big deal.
Right.
And the Higgs boson is the key to proving it exists.
Yeah.
But I'm curious, how does this all tie back to the listener? Why should they care about this seemingly abstract particle?
Well, it might seem abstract, but it's anything but.
Okay.
The Higgs boson isn't just some esoteric concept in a physics textbook.
Right.
It's the reason why the world around us exists as it does. Without mass, atoms wouldn't form.
Okay.
Stars wouldn't ignite.
Wow.
Planets wouldn't coalesce. We wouldn't be here.
So in a very real sense, the Higgs boson is a fundamental part of our existence.
Precisely.
Wow.
And it's a reminder that even the tiniest things can have the most profound impact.
That's such a powerful thought. But I have a feeling there's a lot more to uncover about the Higgs boson.
Oh, yeah.
After all, if it took decades to find it, there must be many more questions to answer and mysteries to solve.
Absolutely.
Okay, So we've set the stage, we understand why the Higgs boson is so important, and now we're ready to explore the even deeper questions it raises. But before we do that,
Yeah. Yeah, it's amazing to think, like, we've come so far in our understanding of the universe, yet we're still grappling with some fundamental mysteries.
right, it's like every answer just leads to more questions.
Yeah.
Our sources touch on some of these mysteries, like dark matter,
Uh-huh.
this invisible stuff that seems to make up a huge chunk of the universe.
Yeah, what's fascinating is that we know dark matter exists because of its gravitational effects. We can see how it influences the movement of galaxies, but we have, like, no idea what it's made of.
Right.
It doesn't interact with light, so we can't see it directly.
So it's like this phantom mass exerting its influence from the shadows.
Yeah.
I guess that's why they call it dark.
Right.
Could the Higgs boson have anything to do with this dark matter puzzle?
That's a great question, and one that physicists are actively exploring.
Okay.
Some theories suggest that the Higgs boson could interact with dark matter particles, providing a way for us to detect them. Others propose that there might be an entirely new type of Higgs boson, one that interacts primarily with dark matter.
Okay, so the Higgs boson might be a key to unlocking the secrets of dark matter.
Potentially, yeah.
What about those other Higgs particles you mentioned earlier? Could there be more than one type of Higgs boson?
It's certainly a possibility.
Yeah.
The standard model, as successful as it is,
Right.
doesn't explain everything.
Right.
There are phenomena we observe that it just, can't account for.
Right.
Some physicists believe that there might be an entire family of Higgs bosons,
What?
each with its own unique properties.
So finding another Higgs boson would be like discovering a whole new species in the particle zoo.
Yeah, it'd be huge.
It could potentially rewrite the rules of physics as we know them.
Exactly.
Our sources also mentioned something called supersymmetry, which sounds incredibly complex.
Yeah.
Is this another theory that could explain some of these mysteries?
Supersymmetry is an elegant theoretical framework that proposes a kind of symmetry between matter particles and force-carrying particles.
Okay.
It suggests that for every known particle in the standard model, there exists a supersymmetric partner particle.
Wow.
A super partner.
Okay, so it's like every particle has a secret twin out there somewhere.
Kinda. Yeah.
And what would finding these superpartners tell us?
Well, supersymmetry could potentially explain several mysteries,
Okay.
including the mass of the Higgs boson itself. The theory also suggests that some of these superpartners could be the elusive dark matter particles we've been searching for.
So finding these superpartners would be like hitting two birds with one stone.
Yeah.
It would give us a deeper understanding of the Higgs boson and potentially solve the dark matter puzzle at the same time.
Exactly. It would be a major step forward in our quest to, understand the fundamental building blocks of the universe.
You know, all this talk about invisible fields and hypothetical particles is pretty mind-bending.
Yeah, for sure.
Do you ever find yourself struggling to visualize these abstract concepts?
Absolutely. It's a challenge to wrap our minds around things. We can't directly observe.
Right.
I find that analogies and metaphors can be helpful.
Okay.
For example, I like to think of the Higgs field as a snowfield.
A snowfield. How so?
Well, imagine a skier gliding effortlessly across a smooth, flat surface that's like a massless particle zipping through space.
Okay.
Now, picture someone trying to trudge through deep, heavy snow.
Okay.
They encounter a lot more resistance.
Right.
Just like a massive particle interacting with the Higgs field.
I like that. It paints a vivid picture. In my mind, it's like the snow represents the Higgs field and the difficulty of moving through it represents the mass of a particle.
Exactly.
It makes me think about that quote from the video script.
Yeah.
The universe has many more stories to tell, and we're just getting started.
That's a great point.
Yeah.
The discovery of the Higgs boson wasn't the end of the story.
Right.
It was just the beginning of a whole new chapter.
It's almost humbling to think about how much we still don't know, but also incredibly exciting to consider the possibilities that lie ahead.
Yeah, I agree.
Speaking of which, our sources mention another fascinating, albeit complex, theory, string theory.
String theory.
Yeah.
It's one of the most ambitious and challenging theories in physics.
Okay.
It proposes that the fundamental building blocks of the universe aren't particles at all,
Right.
but tiny vibrating strings.
So instead of tiny billiard balls, we have tiny vibrating strings.
Yeah, basically.
How does that change our understanding of the universe?
It's a radical shift in perspective.
Okay.
String theory attempts to unify all the forces of nature, including gravity, which the standard model currently doesn't encompass. It also suggests that there might be extra spatial dimensions beyond the three we experience in our everyday lives.
Wait, extra dimensions, like hidden worlds folded up within the fabric of space-time.
It's a pretty wild idea, isn't it?
Yeah.
But it's one that many physicists are taking seriously. String theory is still very much a work in progress.
Right.
But it holds the potential to revolutionize our understanding of the universe even more profoundly than the Higgs boson did.
So we have the standard model, which has been incredibly successful in explaining many aspects of the universe.
Right.
But it also has its limitations.
Right.
And then we have these new mind-boggling theories like supersymmetry and string theory that are pushing the boundaries of our understanding even further.
It's like we're standing at a crossroads in physics.
Yeah.
We have this solid foundation of knowledge thanks to discoveries like the Higgs boson.
Right.
But we're also on the verge of potentially revolutionary new theories that could completely change our understanding of reality.
It's a time of both great certainty and great uncertainty.
Yeah.
And it's that tension that makes this field so incredibly exciting.
I agree.
One thing that strikes me, though, is the sheer scale of collaboration involved in all this. Our sources emphasize the global effort that went into discovering the Higgs boson.
It's truly remarkable. Yeah.
The Large Hadron Collider, for example, is a testament to international cooperation.
Right.
Thousands of scientists from all over the world working together towards a common goal.
Yeah.
It shows what we can achieve when we put aside our differences and focus on the pursuit of knowledge.
It's a powerful reminder that science transcends borders and cultures. And it gives me hope that we can tackle other grand challenges facing humanity with that same spirit of collaboration.
I hope so, too.
But I think we're getting a bit philosophical here. We still have a lot to unpack about the implications of the Higgs boson and the mysteries it has revealed.
You're right.
Yeah.
The journey of discovery is far from over. There's still many unanswered questions, many puzzles to solve.
Right.
But with each new insight, we inch closer to a deeper understanding of the universe and our place within it.
Okay, so we've covered so much ground already, from like the nitty-gritty of particle physics to the mind-bending possibilities of string theory.
It's been a lot.
Yeah.
But I keep coming back to something. Our sources kind of hinted at the philosophical implications of all this. What does the discovery of the Higgs boson tell us about our place in the universe?
It's a question that scientists and philosophers alike have pondered for centuries.
Right.
Where do we fit into this grand cosmic scheme?
Yeah.
The Higgs boson, in a way, provides a tangible link between the vastness of the universe and the very essence of our being.
I'm intrigued. How so?
Well, think about it. This tiny invisible particle, the Higgs boson,
Right.
is responsible for giving mass to everything around us. It's the reason why stars can form, planets can exist, and ultimately why we are here.
Wow.
It's the foundation upon which the universe as we know it is built.
It's almost poetic, this subatomic particle playing such a fundamental role in the grand symphony of existence.
Yeah, it is.
It's a reminder that we're not just like isolated beings on a random planet. We're inextricably linked to the cosmos, woven from the same fundamental fabric of reality. The discovery of the Higgs boson underscores this interconnectedness in a very profound way.
Yeah, and I think it shifts our perspective a little, doesn't it? It invites us to see ourselves not as separate from the universe, but as an integral part of it.
It's both humbling and awe-inspiring, but it also makes you wonder what other fundamental principles are out there shaping the universe in ways we haven't even begun to imagine.
I mean, that's the beauty of science, right? It's a never-ending journey of discovery.
Right.
Every answer leads to more questions, driving us deeper into the mysteries of the cosmos. The Higgs boson was a monumental discovery, but it's certainly not the final word.
So what's the takeaway for our listeners? What should they carry with them from this deep dive into the world of the Higgs boson?
I would say this. The next time you look up at the stars,
Yeah.
or simply marvel at the world around you, remember that you're not just an observer. You're a participant in this grand cosmic dance. And the very essence of your being, the mass that defines your physical presence, is a testament to the intricate workings of the universe, to the power of invisible fields and the elegance of fundamental laws.
Beautifully said. It's a reminder that the universe is full of wonder. and that we're all a part of something much greater than ourselves.
Yeah.
Thanks for joining us on this incredible journey into the heart of matter.
Yeah, my pleasure.
Into the mystery of the Higgs boson.
Thanks for having me.
Until next time, keep exploring.